Welcome to Angles and Acid, where we learn things maths and science. In today's video, we are learning about factors and multiples. So the concepts themselves are very simple, so they're not going to take a lot of brain power to learn. However, how you find a factor, that can be a little bit hard work. So I'm going to show you some strategies that you can use to try and find factors. And this is really helpful like down the future in terms of simplifying fractions and cancelling things out. If you can find factors and pull them out, it is one of the most useful tools to simplify a problem that is seemingly very difficult. However, because I'm going to teach you some of the strategies in the middle, this video will be a little bit longer than usual. So what is a factor? Well, a factor is a factor of a number is something smaller that can divide the original number nicely. That means there's no remainders, there's no decimals, there's no fraction leftovers. So I can give you an example here. So 15 has several factors, so you can divide it by 1, which is not really helpful to know. You can divide it by 3, you can divide it by 5, and you can also, of course, divide it by itself. So 1, 3, 5, and 15 would be said to be factors of 15. But, okay, that's the concept. It's not that difficult. But how you find factors, that's not always intuitive. That's not always obvious. Yes, 15 is obvious because you are familiar with it and you know all the numbers less than 15 that can divide it. So yes, that's probably easy, but what if you get a number that's like 3 digits long and you haven't seen it before? You can't necessarily tell what all the factors are. How do you find them? So let's explore that. So first recommendation I would say is start with your times tables. If you know your times tables, you know this times this will give you this number, then you'll get a memory bank of all the possible numbers that can be that have factors. So for example, 64, if you see it, you know, oh, that's just 8 times 8. So you already have a factor. If you see 27, you know that's 3 times 7 because that's part of the times tables. So that can help you, particularly for small values. But if we're looking at larger numbers, what can you do? Well, you can start trying to find them using factor trees. So I sort of noticed this by someone else doing this at work. Basically, you take the original number and you sort of pull out a factor and its corresponding multiplier. So I'll just do an example. It'll be very obvious once you see it. So 64, it's an even number. So I'm going to start with it. Obviously, 64 is divisible by 1. That's obvious. It's not really helpful. Let's go to the next number on the list. Divide it by 1? Yes. Divide it by 2? Okay, let's have a look. Well, it's an even number, so obviously I can divide it by 2. 2 times what gives me 64? So 32. I'm just basically eyeballing it. You know, half of 4 is 2, half of 6 is 3. That's how I've come up with 32. Okay, so I've already found 2 factors, but can I also break 32 into smaller factors? Yes, I can. It's an even number, so let's bring out another 2. 2 times what gives me 32? Well, 16 will give me that. Okay, 16 is another factor. Can I break that down as well? Yes, I can. It's also even, so I'll get 2 and 8. Can I break 8? Yes, I can. 2 and 4. Can I break 4? Yes, it's 2 times 2. So after I've done that whole tree, I know all the possible factors that are to do with the number 2. If I've done that tree, I would try to see if the original is divisible by an odd number. So maybe I'll try and look to see if it's divisible by 3 or 9 or 7 or something like that. And you would make a different tree, okay? But 64 is an even number. It's not going to be divisible by 3. Now I can basically just write a long list. So 64 itself is obviously a factor. 32 is a factor. I'm going from biggest to smallest just to make sure I don't miss any of them. 16, 8, 4, and 2, and obviously 1, which is the useless case, which isn't very helpful. What if you don't know if it's divisible by 3? How can you eyeball it? Well, I came across this list of divisibility rules. I've never seen them in my life, so this is really handy stuff. I'm going to make a little list and keep them somewhere so I can personally reference to them. But there's some really cool ones in here. So obviously, all numbers are divisible by 1. For 2, basically looking for any even numbers. So usually the last digit will be a 0, 2, 4, 8, 6. Okay. For divisible by 3, you would have to add all the digits, and then if that sum is divisible by 3, then the original number must also be divisible by 3. For divisibility by 4, the last two digits. So if I've got 1, 2, 4, 24, is 24 divisible by 4? If so, then the entire 124 would be divisible by 4. 5, obviously it'll have to end in a 5 or a 0. You kind of notice this from the find times tables. 6, it would have to be divisible both by the number 2 and also divisible by number 3. For 7, the book I found doesn't mention if a technique for finding if it's divisible by 7. So I think you're kind of on your own there. Knowing your 7 times tables would probably be helpful. Number 8, the last 3 digits must be divisible by 8. So if I've got 2, 3, 4, 7, then those last 3, whatever that number is, I've forgotten, whatever those 3 numbers are, so that 3-digit number, if that's divisible by 8, then the original number will be divisible by 8. 9s, basically add all the numbers together, and are they divisible by 9? And 10s, that's really easy, they always end in a 0. Okay, what if all those techniques fails? What do you do? Like, for example, if you see a number, like, is it divisible by something larger than your times table? So if it's larger than 13, how do you check if that's a factor? Well, I think last resort is to do short division. So I've got a couple examples here. So is 14 a factor of 195? That's basically asking you, can 14 divide it nicely with no remainders? So I don't know a 14 times tables. Do you? Probably not. So basically short division, we're going to try and solve it. So 14, let me just get my brush. Okay, how many times does 14 divide 19? Okay, so it fits in there once with some leftovers. So 9 and 4, the leftovers would be 5, so 55. Now I have to do the 14 times tables, which I don't know, so I'm just going to list them off. So that's 1 time, that's 1. Twice would be 28, 3 times would be 42, and then once more would give me 56. Okay, so 14 times 3 would fit in there with some remainders. So because there's a remainder, because there's going to be some remainder, it's obviously not going to be a factor, so it's not a factor. Easily done, let's move on. So is 15 a factor of 195? Well, a clue there might be that they both end with a 5, so they sort of divisible by 5, both these numbers, maybe they'll fit. So let's try this one. So how many times does 15 fit into the number 19? Well, it's going to fit in there once with some leftovers. In this case, it's going to be a 4. 4 is remaining, so that makes it 45. How many times does 15 fit into 45? Let me check. Let's see. 15 times 1. 15 times 2 is 30. 15 times 3 is 45. So yes, so it fits in there 3 times, no remainders. So yes, 15 is a factor of 195. Whew, that was difficult. Right, let's move on to another thing which we call multiples. So let me just hide this layer. A multiple of a number is basically 1 times the original, 2 times the original, 3 times the original, and so on. So basic example here, let's try and find some multiples of 13. So obviously 13 is just itself times 1. I can do twice that, which would give me 26. I can do 3 times that, which would give me 39, and so on. So I can easily find some multiples of that. So it's a really simple concept. How do you find multiples? Well, you can just use multiplication. So take the original number and multiply it by 1, multiply it by 2, multiply it by 3, and basically see what you get. Or you could take the original number and add it to itself over and over and over again and see what numbers come out. That's another way of doing it. Okay, so we're at the end of the video. Thank goodness. I'm going to leave you with some practice questions so you can try some of the techniques I just showed you in this video. So question 1, 2, let me just clear this layer, sorry. So questions 1, 2, 3. If you could answer in the comments down below, and I will put a heart on the people who get the answers correct, so that the rest of you can check your answers against that one, whoever got it first and whoever got it correct as well. So I'll catch you guys in the next video. I don't know what it's going to be, but I will leave you a link right over here to click on, and I'll catch you later.